There are four essentials in finite difference modeling. Very important four conditions. One is called the condition of consistency. What it actually means is that your finite difference equation converges to the differential equation for very small time and space steps. Okay, so which means if you use very, very small time steps, so you should actually go back to the original equation and not something else, called the condition of consistency. There's also the condition of accuracy, which means this. So model iterations involve two types of errors. One is called the round-off error, and this is related to the technology of a computer, because computers cannot 100% represent all digits of a number. Okay, so there has to be some round-off. Some digits will be ignored. The second type of errors are truncation errors, and that's the error associated with the numerical scheme that you use, like the forward difference that you used for this paper. So both errors need to be kept as small as possible. You need to use the best scheme and maybe also the best computer. The third condition is called the condition of numerical stability, and this is just to do with stability condition. Certain stability criteria have to be satisfied, otherwise values increase exponentially and the model crashes. And you will be forced to actually satisfy this condition, because otherwise it's just, as I said, the model crashes. No result at all. The fourth one is very important. It's called the condition of efficiency, and it's to do with the time it takes for the completion of a numerical simulation. That's one aspect. And the second aspect is how much space do you need to save data, output data. And often you have to make a compromise. So, for example, when I did my PhD, I studied convection in polar regions with a numerical model. Anyway, so that it took more than 1.5 months each simulation. So we had a supercomputer in Hamburg at the climate research center, and it took 1.5 months to make one simulation. And you couldn't do that many simulations, so everything, or most everything, had to be perfect to avoid a loss of time. Okay, because think about, you go submit your job, and 1.5 months later it turns out that you made a mistake. You used the wrong parameter. Is really tricky. You think that the technology is much better now, but it's still, you face the same problem, because it's tempting to use very high resolutions. It still takes a very, very long time to simulate. Space is another big problem. In particular, if you have three-dimensional models, space is a severe problem. You need to save all your data. Okay, that's really four important conditions, very important for you to learn. And I'm pretty sure that if there's an exam at the end of this topic, there will be definitely a question talking about for essential. Okay, so let's keep that in mind.